So in this problem, we have income flowing continuously into a manufacturing company at this rate. Actually, it's an interesting rate because the rate at which it flows depends on what year it is, where T is the number of years from now. So first we're going to find the total money flow. That is just how much money comes in over the next 5 years. Okay, so total money flow is the integral of the rate. This is a little bit simpler than parts B and C. So total money flow is going to be the integral of the rate at which it's flowing. Now normally you see rates as like $10,000 per year or $80 per month. This is a strange rate because it has a variable in it, but it doesn't change the fact that it's still a rate. So total money flow would be the integral from 0 to 5 of this rate at which it's flowing. And that's pretty computational. I'm going to leave you to compute that integral. Parts B and C are what I think most people are stuck on here. So let's find the future value of the money stream if the income is invested at 8.5% compounded continuously. Well, that's this down here. Because we have money coming in continuously at this rate, so that's actually equal to F of T. So F of T is the flow of rate of money. So F of T is 36,450 times e to the negative 0.052t. Okay, let's see now. We want to find both future value and present value. I'm actually going to find present value first because it'll make the problem slightly easier. First, we're going to find present value. Capital T is the total time interval that you're looking at. And this problem it doesn't explicitly say it, but we're just going to use 5 years. It says it in Part A, and it's implied that that's what you're dealing with 5 years in Parts B and C. So we're going to let capital T equal 5, and then let's set up the integral from here. So for the present value, it's the integral from 0 to 5 of the rate, 36,450 times e to the negative 0.052t. That's F of t times e to the minus rt. So times e to the minus r is the interest rate at which it's being compounded, so 0.085, negative 0.085t dt. Okay, so before we integrate, let's pull out this constant, 36,450. And let's also combine these two e's. When you have the same base and different exponents, you can combine them by adding the exponents. So negative 0.052t minus 0.085t is negative 0.137t. Let's go ahead and integrate that. 36,450 times, I'm not going to do this fully through, but I'm going to do a little bit. So times 1 over the coefficient of t, so 1 over negative 0.137 times e to the negative 0.137t. I'm going to take that from 0 to 5, so plug in 5, minus plug in 3, so 36,450. We'll go ahead and put the negative right there, over 0.137 times e to the negative 0.137 times 5 is 0.685. Minus e to the 0, and I think you can get that from there. Let's go on and find future value as well. Let's do the setup for that. So for future value of the annuity, it's equal to the rate it's being compounded at, which is e to the, we're still at 8.5%, so positive 0.085. That's the interest rate, R, times capital T, so times capital 5, times the integral from 0 to capital 5 of the rate, f of t here, 36,450 e to the negative 0.052t, that's f of t, times e to the minus rt, so times e to the minus 0.085t dt. Now you'll notice this is the same integral that we just computed, actually. So in fact, what you probably want to do is go ahead and compute this. I think let's just go ahead and do it so you can see what I'm saying. So bringing up the next calculator over here, let's compute this value right here. Okay, so we have negative 36,450 divided by 0.137 times e to the power of negative 0.685, close that parenthesis, minus e to the 0 is just 1. Okay, so we get, what was that? 131,940 and change 96 cents. Okay, so that is what this integral is equal to. So I'm going to use the unrounded version. So over here we have e to the 0.085 times 5 is the 0.425. Okay, times this integral, but I'm going to do times this, unrounded definitely here, so that I don't have any rounding errors. So 131,940 0.9572. Now that's still being rounded there, so in order to avoid a rounding error, I'm just going to go to the calculator and put that particular answer times this out here, e to the 0.425. 201,815 and 62 cents.